Hello, hi, this is G. Kusumant of Bennett University. Today I am here to discuss about my machine learning assignment in which we are using classification techniques like CART, Logistic Regression, Random Forest, Decision Tree, Neural Networks to classify the pH value based on RGB colors. Firstly, if we come to our dataset, name of my dataset is pH dataset, in which there are totally and 653 rows. The four columns here are blue, green, red, and label, and I have 653 samples. 653 samples. Now, in this assignment, I will first load the data, pre-process my data, and then I'll split the data into training sample and testing sample. Using the classification techniques, I find the accuracy of the model. Classification techniques like I said it before: CART, logistic regression, random forest, decision tree, neural networks. And then I'll analyze the different classification metrics like MSE, RMSE, precision, recall, accuracy, etc. And at the last I'll conclude which is the best model suitable for my dataset, so that I'll classify the dataset in pH value based on RGB colors. So we are going to start and look how my dataset is and how I load it and use the classification techniques, and then I concluded which is the best model. Here firstly we'll go and load the data. We'll use the pandas, and then we'll use the read function ph.database.csv. And as I said, there are four columns: blue, green, red, and label, and there are a total of 653 rows in my data set. And now my target variable or the target column of my dataset is the label, which is one of the column which is above mentioned. I just want to use the label as my target variable, so that I want to use the label as data. So for using data label as my target, I will be dropping the label from the column list, so that I get the dataset with only 3 columns, leaving the label behind. And now we will be pre-processing my data so that it will be easier for further classification techniques. Here I will be classifying the data, and then I will be pre-processing. I'll be pre-processing it. Next, we will be classifying data using the classification techniques. Now we have been splitting our data into training sample and testing sample. Here if you see, there is test size is equal to 0.3. This means we are splitting our data set in the ratio test to train 0.3 is to 0.7. For example, there are 100 samples. We will be dividing in a way that 30 samples are going to test sample, and the remaining 70 are going for the training sample. That is how the splitting of the data is worked. And now we will be going to use classification techniques. Firstly, we are seeing the decision tree. Here we are using entropy as a criterion. So this is ID3. Using this ID3, I have developed and saw I got an accuracy score of 0.698, which is approximately close to 7. And then by plotting a graph for the ID3, I got a graph in this way. This is my graph for ID3 for my data set. And then now I'll be using the CART classification technique. Here in this CART classification technique, the main criteria is Gini impurity. By using the CART technique, I got an accuracy score of 0.714, which is greater than the decision tree, the ID3. And by plotting the graph of the CART, I got a graph in this way. This is the graph which I got on ID3. Now I'll be using the perceptron technique to classify my data. Here I use the perceptron techniques to classify my data and I got the accuracy score of 0.260, which is way less than the previous things. So I'll conclude this later. And then the neural network. Here, by using the neural network, we have classified my data, and then this is the classification report I got on this. This is precision we call F1 score and the support. And now I'll be using logistic regression. By using the logistic regression, we use sklearn for this, and then we are seeing the CLF score. It is figured out to be 0.5. And then we'll be framing our dataset with classification technique random forest, which this is another technique which is used, and then by using this technique I got a accuracy score of 0.505, and then we'll be doing it for the naive base using sklearn.naive.base. We'll get the accuracy score of 0.50. It's approximate to 0.51. So by doing all the classification techniques hereby, I could conclude that I get my highest accuracy in card, which is 0.714. We get it 0.714 for the card data classification technique. So hereby I conclude that card classification technique and the decision tree classification technique are one of the or two best techniques for classifying the data. Thank you.